Hello, my name is William Johnson, and I will be presenting Lab 1, Physics 2211, which covers the constant velocity of a rolling glue stick. In this lab, I will be introducing key concepts and principles, analyzing the glue stick's motion via tracker. I will identify the computational model via glow scripts, and I will compare the predicted results to my computational results. Finally, I will answer the what if and what does it mean. The purpose of this lab is to analyze the motion of an object as it moves at a constant velocity to determine its position over time. I will also design a computational model via GlowScript to replicate a real-world scenario. I will compare the computational model to the video analysis and identify the key differences. When comparing both these models, the observed model had a greater average velocity than that of the predicted motion via the computational model. Two key concepts within this lab are Newton's first law and Newton's second law. Newton's first law states an object in motion will stay in motion and an object at rest will stay at rest, unless acted upon by an unbalanced force. Newton's second law states that a force applied to an object at rest will cause the object to accelerate in the direction of that force. This can be demonstrated in these two equations, the position update formula and the velocity update formula. The position update formula is represented by the final position is equal to the initial position plus the average velocity times the change in time. The velocity update formula is demonstrated by the final velocity is equal to the initial velocity plus the net force divided by the mass times the change in time. When the net force is zero, the object is either at rest or moving at a constant velocity and will remain this way until an unbalanced force acts upon the object. In this lab, I selected the glue stick as the system and the rest of the room as its surroundings, and assumed friction and air resistance were negligible. I used the y-axis in tracker as my x-axis due to the video being flipped when entered into the program. I used the up direction to be the positive direction on the x-axis. Here's the code I used for the computational model. I changed a couple things from the starter code, such as the changing of the system mass to the mass of the glue stick. I also changed the initial position to equal the position at time equals 0. And I also changed the initial velocity to equal the change in initial position divided by the time between one frame. I added the time of one frame as the size of each timestamp, as represented by the delt at variable. And then I added the position and velocity update formula so the program properly calculates each new value for position and velocity after each frame. Here are the values of each model graphed on a singular chart, with the blue representing the observed model and red representing the computational model. Due to the slope of the observed model being steeper, the velocity is greater for the observed model. Some more observations for this graph come in the next slide. The observed results and predicted results appear more similar the smaller the value of time is. The tracker results show that the glue stick moved at a higher velocity than that of the glow script results, as illustrated by the steeper slide line generated by tracker model. The difference in positions and velocities collected by the two models, coupled with the inconsistent data points collected via the tracker model, reveals the velocity did not remain entirely constant throughout the given time. The velocity most likely did not remain constant due to forces acting upon the glue stick, such as friction or air resistance. If I were to flip the axis, this means the up direction would become the negative direction and the down direction would become the positive direction. In this case, the positive values would become negative instead of positive. When an object moves at a constant velocity, it can be assumed that the net force is 0. However, it is impossible to determine just how many forces are acting upon the glue stick that is causing the net force to equalize to 0. There are so many different forces present on Earth that can lightly or heavily impact the motion of an object, so it's important to determine which ones are currently in play. To wrap this up, in Newton's first and second law, friction, gravity, air resistance are examples of the unbalanced forces that can cause an object at rest to move or an object in motion to stop, speed up, or slow down. In real life, it is impossible or extremely difficult to achieve a perfect constant velocity due to many forces that are constantly acting on objects, such as gravity, friction, and air resistance.